is the group 1 carbonates are much more thermally stable than the group 2 carbonates. State and explain the trend of thermal stability of the group 2 carbonates. So you can write, first reason would be pore size. The size of M+2 increases down the group due to which there is a decrease in charge density. Thus, the decreasing the polarizing power and increasing thermal stability. That will be the reason and their trend. A student electrolysis a solution potassium iodide for 8 minutes by using a direct current. Half equation of that reaction is given to you. Write a half equation for that reaction that occur at the cathode. Means the equation at anode is given to you and he needs to know the equation for the cathode. So you can write, or on the anode there is a gain of electron, losing of electron means oxidation seems to happen. So in cathode there will be reduction. So you can write 2 is positive. Also write their states. You know that whenever hydrogen or any element is losing or gaining that electron, it should be in aqueous state. So 2 is positive in aqueous form plus 2 electron negative. It's making us H2 gaseous state. That is the half equation as cathode. After the electrolysis, the iodine produces requires 21.35 cm cube of 0.100 mole per dm cube of Na2S2O3. React completely calculate the average current that is used for 8 minutes during the electrolysis. It means that you need to find that Q, which is equals to I times T. So you need to find I. So in order to find I, you must have the value of T and Q. T is given to you, that is 8 minutes. You have to convert it into seconds first, and you need to find the value of total charge first. So you can use the equation as IT over charge of electron times by L, which is equals to N times by Z. N is the number of moles and Z is the molar constant, that is times it by. So you can write I value is basically you need to find, so it will be treated as it is, times it by time is how much, it's 8 minutes, so convert it into seconds. 8 times by 60 seconds, whole dividing by charge on that electron, that is basically 96,500, which is equals to n times by z, that is given to me 21.35 cm cube in 0.100 mole per dm cube of solution. So you have to convert it into meters you have to convert it into dm cube first, so it will becomes 2.135 times it by 10 raised to the power negative of 3. You need to find I, so you will subtract your equation as I, that will become 0.43 ampere. So that is the average value of current, 0.43 ampere. Ki is used as a source for iodide ions in organic synthesis. The example is given to you in that diagram. So step 1 to step 2, there is a nitration. Step 2 to step 3, there is acylation, or also there is attacking of iodine over there. And then step number 4, after attacking of electrophile to nucleophile, you can see nitrogen gas is released. Here you have to simplify or express the reagent for the step number 1 and step number 2. So you need to find the behavior either for step number 1 or step number 2. So step number 1 suggests that there is attaching of NO2 group. It means that nitration is going to happen, and nitration is always possible at the presence of concentrated nitric acid, HNO3, concentrated nitric acid, and concentrated hydrochloric acid, HCl. In step number 2, you can see nitration to amine, means you want to make nitrobenzene to amine group. That nitro group is replaced by amine group. That is always possible at the presence of tin plus concentrated HCl. Concentrated HCl. So you will write your equation, means your reagent as step number 1 it was concentrated HNO3 plus concentrated HCl, and for step 2 you used tin plus concentrated HCl. First is because of nitration and another one is amine. Okay, complete that equation NaNO2 plus HCl, and also explain the equation for the stage 2, means the second reaction. So the first one could be written as NaNO2 plus HCl could be converted to HNO2 plus NaCl and stage number 2 it will become HNO2 react with that much to produce that thing. So HNO2 will make a reaction with C6H5NH2. So HNO2 plus C6H5NH2 will produce C6H5N2 positive. That will be the product. The iodine ions forms Ki with the reacts with D in the step number 4. The mechanism is shown to you. Suggest the name for that mechanism in the step number 4. In the step number 4, you can see iodine is attacking over that benzene ring. So iodine seems to be electron rich. It's going to attack over here. So iodine is acting as a nucleophile. So there will be a nucleophilic substitution reaction, because iodine is attacking over here and substitute the nitrogen here. So it means that it is acting as a substitution. Iodine is replacing nitrogen and make a bond with it. so it means that there is substitution. But what type of substitution this is? This is nucleophilic substitution, because iodine is electron rich and that bond nitrogen is electron poor. So iodine is attacking over here, so it means that that will be acting as a nucleophile. Substitution is going to happen, so that mechanism will become nucleophilic substitution. Nucleophilic substitution, that will be the name of that mechanism.